Good afternoon, everyone. We will be exploring these type of derivatives in slightly more detail with a slightly more emphasis as well in this video. Let's start with this question. Y is equal to x cubed plus 2x times e to the power of x. I'm running through some questions here from a calculus textbook. We'll run through these questions. These are end of chapter questions. We're going to run through these type of questions. Look over here. We have a function here, f, function here, g. We're thinking about the product rule in place. We're going to do the product rule template. It's not going to be too hard. You'll do the g function because we're finding the derivatives over here. Derivatives of this function over here. We'll do the g function times the derivative of the f function. Remember, the more of these you do, the more easy they get. Plus the f function multiplied by the derivative of the g function, and we're looking here primarily at exponentials. So you have the f function here multiplying by the derivative of this polynomial, which will follow the power rule that I've talked about. When you do the derivative of x cubed plus 2x, you're going to get 3x squared plus 2. Not hard. And then you do x cubed plus 2x times the derivative of e to the x. It follows this scheme, becomes ae to the ax, especially if you have a coefficient here of a and you're doing the derivative, it follows this scheme. Well, e to the x derivative is just e to the x. Now look over here, find the commonality and isolate it. You get 3x squared plus 2 plus x cubed plus 2x. Finalize everything here, e to the power of x into x cubed from a high order polynomial to low order plus 3x squared plus 2x plus 2, and it seems like this question is done. Let's look at this next question over here. And here's the template we're following for the exponential, the basic exponential function derivative. You see it right over there. Now look over here, we have ax cubed. When in doubt, and you're seeing a similarity here, but you're not seeing a clear similarity. Like I said, when in doubt, you can't go wrong with the chain rule. You can just do that. U is equal to ax cubed, because the chain rule just basically eliminates the doubt, because it gives you a confident or a reliable set of process for doing a question. With regards to u, you get e to the u, and then you just use the chain rule to help eliminate the doubt. The doubt only arises because of these different types of variations you can see over here. That right there is the doubt. Now look over here, a here serves as a coefficient. It doesn't serve as any kind of a variable, and you can rewrite everything as this. Look, derivative with respect to u, e to the u, and bring the a out over here. Now do the derivative of this x cubed. Now look how your question will change and how it will proceed. Derivative of e to the u is going to be just e to the u. It's no different than following that scheme. You'll still have this a over here, and then x cubed will be 3x squared. And when you do all of this question to the finality, a will come at the very beginning and followed by 3x squared, or you can do 3x squared a and then followed by e to the u, which was ax cubed. And you can, if you want, write it this way, 3x squared a e to the ax cubed, and this right here would be a final answer. Both of these are identical, except I wrote a first here and I wrote 3x squared first over here, and your question would be done. Here's the third question. In all of these questions, we're looking at exponential basic derivatives, but we have a variation occurring here in the exponent. As always, when in doubt, if you cannot see a clear relationship to this scheme or the template here, well, when in doubt, use the chain rule. Let u equals 1 over x, f of u is equal to e to the u, and then you just proceed in that manner, because we're doing the derivative of this function over here, d over du, e to the u, and then du over dx. And you know what? Over here, when I'm going to proceed with this question, I'm going to make a little change over here. Instead of writing 1 over x, I'll write x to the power of minus 1. You see, instead of writing 1 over x, I'm doing x to the minus 1. Where I'm staying in tune with what I said in the polynomial derivative, as anytime you have this, use an exponent and bring in a minus, because it helps you make this into a more friendlier format. When you do the derivative of all of this, the du, e to the u becomes e to the u. It just stays as that. This x to the minus 1 becomes minus x to the minus 2 if you follow the scheme of the power rule. And you know this, minus 1 will come over here and this exponent will be reduced by 1. You'll get this. So you can bring the minus first, and you can bring e over here with its u, which is 1 over x, and then the x squared can come down because of the negative exponent. So you get negative exponent makes it reciprocal. So your final answer is minus e to the power of 1 over x divided by x squared. We can write it a little more cleanly over here, minus e to the 1 over x divided by x squared, and this right here will give you your slope of the tangent line or your instantaneous rate of change, however you want to call it, but that right there is your final answer. This question is interesting in the fact that these are all questions I'm taking out here from a single variable calculus book, but it's interesting because we have a composite function. Within the composite function, we will have a product rule playing into place. But again, if you don't see this template over here, easily do the chain rule, and that's what I'm going to do. Let's say u is equal to x sine 2x, and you know the sine over here in itself is a composite function, and then f of u is going to be e to the u, and you'll proceed in the chain rule manner. You'll have e to the u, and that's going to be a common theme over here, is we're looking at these type of questions where this aspect, the exponent, is becoming increasingly difficult or is becoming more confusing. Then we write x sine 2x, but over here, as you can see, we have a product rule we have to worry about. So we go to the next line and we initiate the product rule. Here's my f function, here's my g function. We'll do the g function sine 2x, and the g function in itself is a composite function times the derivative of x plus the f function times the derivative of this. But I want to bring a chain rule over here. If v is equal to 2x, then f regarding that v is equal to sine v, and that's what we have to do here, sine v. We get derivative with regards to v sine v, and the derivative of that v with regards to its x, we have 2x, and we just have to open this up. E to the u will stay as e to the u with its derivative because it's following this basic scheme, except we can replace the u with what it stood for, x sine 2x. We can do that substitution right here, nothing wrong with this. Now look over here, sine 2x with the derivative of x, which is just a 1, is going to stay as sine 2x. Now look over here, x will multiply by the derivative of 2x, which is just 2. So 2 times x is 2x, and derivative of sine v will be cosine. Derivative of sine x is a cosine x, derivative of sine v is a cosine v, but we substitute back for that v, and this is what we get. This next question over here is not a difficult one, it's a composite function. All of this is under a radical, and y is equal to that, and again we're tasked with finding the derivative of this, because this represents the equation of some model we are interested in. The derivative will represent your instantaneous rate of change or the slope of your tangent line. And you know you have to proceed here with a substitution because we are having a composite function right from the very beginning. Look over here, u is equal to 1 plus 2e to the 3x, and this over here can represent a composite function, but we can worry about that when the time comes. We'll have root u. The function with regards to u is root u, and we proceed with the chain rule. It seems like that in this set of questions from this textbook, the chain rule is being addressed over here with regards to the exponential derivatives. Look over here, 1 plus 2e 3 to the x. Now this right here is nothing too fancy. Look over here, derivative du root u. Let's bring a parentheses over and let's do a new set of derivatives over here of a polynomial. Derivative of this constant plus 2 times the derivative of this 3 to the x. Look over here, you can always bring this 2 out as a coefficient. You can bring it out and followed by the derivative. Now look over here, we can get fancy over here and do a new set of substitutions. V is equal to 3x and f of v is equal to e. We can just look over here, we classically have the case over here. The 3 will come down as a coefficient over here, and we'll follow exactly this scheme right over here for this question. So let's open this up. Derivative of root u is 1 over 2 root u. But what was u? U was everything over here, 1 plus 2e to the 3x, that was u. Now we're multiplying this by this. The derivative of 1 is a 0, we don't even have to write that. And the derivative of all of this over here will be 3e to the 3x. Following exactly this scheme, e to the ax is ae to the ax, ae to the ax. Now look over here. If you can bring this into a 6, you can, but you can recognize that this 2 over here will cancel with this 2 over here because everything is multiplying. And what you will get here in the numerator is 3e to the 3x. This right here will be your derivative divided by the square root over here of 1 plus 2e to the 3x. And you would have a good, clear final answer and you would be done. Now let's look over here. We have a function f of x or y is equal to e to the power of x. Look over here. This right here, this whole aspect over here is your exponent. The exponent is the exponential function. So it's pretty interesting. You can only proceed this by either looking at it this way or by doing a chain rule. And when in doubt, use a chain rule. And I have a bit of a doubt, so I'm going to use a chain rule. If u is equal to e to the x, then function with regards to that u is equal to, with regards to that substitution, e to the u. See, e to the u. Good. Now derivative with respect to u, e to the u times du to the dx is equal to e to the x. See, this right coming over here. The only reason why I had a doubt over here is because these questions are getting fancier by the minute, because I am picking them out here from this calculus textbook. So look over here, derivative of e to the u is just e to the u. Easy. Derivative of e to the x is just what? E to the x, because it's just really e to the ax, where a represents a coefficient of 1. 1 comes over here, you retain the same. Now all you gotta do is plug in your substitution. You have e to the ex times e to the x, and you're done. This right here is your final answer. You're done. This will be an interesting question because we are tasked with finding the equation of the tangent line for this function over here, e to the 2x times cosine pi x at a point 0, 1. We have to find the equation of the tangent line over here at this point, which exists on this curve. And you know, when you're looking at this, you have f and a g function in a product. You're going to be using the product rule over here. You have the f function, the g function. You have to use a scheme or the template for the product rule. So when we do the derivative over here, we proceed exactly as that way. We'll have the g function cosine pi x multiplied by the derivative of the f function, which we have to do, plus the f function, which will multiply now by the derivative of this composite function. If u is equal to pi x, then f regarding to u is equal to cosine of u. And that's how you gotta lay it out. Cosine u and then du over dx is a pi x. Now look over here, in the next step, we start bringing in the actual derivative answers. Cosine pi x stays as such. E to the 2x follows exactly this scheme over here. And it's gonna be ae to the ax. You'll have 2e to the 2x, so that was not hard. Plus e to the 2x multiplied by the derivative of cosine u is a minus sine u. Multiply the cosine of pi x is just a pi, because this right here follows a power rule. Remember back to the derivative video on the trigonometry, the polynomial, and we talk about the power rule. It's exactly that, very easy. Now look over here, let's write everything up in a more clear manner. Cosine pi x times 2e to the 2x. This minus converts as positive into a minus. E to the 2x, bring the pi, and then sine pi x. Now look over here. Are there common terms we can deal with? We have e to the 2x, we have e to the 2x. We can do that. Let's isolate e to the 2x. When you isolate it from this first component, you get 2 cosine pi x. When you isolate from the second component, you get pi sine pi x. But now look over here, we're not done. We have to actually look at the equation and the slope. We have to find the slope by plugging in this x value of 0. From that slope, we'll use a y equals mx plus b to find the equation of the tangent line. We have to look at this x value. When you put this x value of 0s over here, what happens? We have e to the power of 2 times 0. This will just become 1, because anything to the power of 0 will become a 1. We'll have a 2 of a cosine of a 0, because the x value here of a 0 will 0 out this pi x and make it a 0. Cosine of 0 is just a 1. Minus all of this right here will become a 0. Sine of a 0 is a 0, and then pi times 0 is a 0. You get left with zeros over here. But look over here. What do we get? We get 1 times 2 times the cosine of 0, and our slope is just a basic 2. If you follow this out, it's a 2. So m is equal to 2. Now look at the equation. Y is equal to mx plus b. And you have x value, y value is equal to x value times your slope, which you calculated 2 plus b. B intercept here is a 1. So when you redo the final equation, you have y is equal to 2x plus 1. And this right here is the equation of your tangent line. Y equals 2x plus 1. And you're done with this question. This question serves as our last question. Again, it's a similar question. We have a function over here, and we have a point on that function on this curve, and we have to find the equation of the tangent line. When you're looking at something like this, you don't need to be worrying about the logarithmic differentiation, bringing in the logs. to simplify and then doing implicit differentiation. You don't have to, because we're dealing with exponential derivatives, for which there's a very good and basic scheme you can follow, especially when your exponential derivative question is so easy. You have to basically follow here the quotient rule and proceed in that way. And we're going to find the derivative, because the derivative will give us a slope, and we'll plug in this x value into that derivative to get the clear slope, and then we'll use that in the y equals mx plus b format to find the equation of the tangent line. Then we'll be done with this video. Let's use the quotient rule. Here's my f function, here's my g function. So let's use the quotient rule template over here. We have the g function multiplying by what will be the derivative of the f function minus the f function multiplying by the derivative of the g function, which will be easy over here, divided by g function squared. And in this next step, let's do the derivative. X times the derivative of e to the x is just x e to the x, no change. E to the x times the derivative of x is just e to the x divided by x squared. You can isolate over here. E to the x goes in both of these, x minus 1 times, and you have x squared. This right here represents your derivative. This right here is your derivative. Now all you have to do is plug this 1, because this right here is your x comma y. Plug this x value of 1 over here. Look what happens when you plug 1 over here. Right, 1, you get 1 minus 1, you get 0. You get e to the x, which is e to the 1 times 0 over 1 square, everything with 0. So your slope over here is going to be a 0. But that doesn't mean your function is bad. It just means slope is a 0, you have a horizontal line. That's all what it means. Nothing more than a horizontal line. Anyhow, your equation is y equals mx plus b, right? Y is equal to 0x plus b is equal to e. So your equation line of a horizontal line is going to be y equals e, and that'll be it, because there's no slope. It's a flat line, a horizontal line representing the tangent line. Y equals e will be your final answer, and that right here is the equation of your tangent line. Before I end this video, this is just a bonus question I'm presenting over here to do the closure of this topic. We have the product of two functions. Here's one and here's another one. We have composite functions here in play. We use the product rule. The f function, the g function multiplied by the derivative of the f function, which is e to the minus 4x, which will be solved, and the f function multiplied by the derivative of the, which we have to do, chain rule over here, sine 5x. Look over here, you can follow exactly what you see over here. The minus 4 comes over here, minus 4e to the minus 4x. Nothing new over here. E to the ax is ae to the ax, easy. Plus e to the minus 4x. Derivative of this, let's use the chain rule. Sine u, I'm doing this in my head, du dx, 5x. You can do it in your head too, nothing wrong with that. Look over here, sine 5x. I'm bringing this minus out here at the very beginning with the minus 4. See, minus 4, I'm bringing it out here. You can do that. E to the minus 4x plus 5 e to the minus 4x. Derivative of sine u is cosine, and the u was 5x, cosine 5x. Now, you have to look for common terms over here. I have e to the minus 4x over here. I have e to the minus 4x over here. And I have a no other common term over there. No other common term. It's e to the minus 4x. We'll multiply with all of this over here. You have minus 4 sine 5x plus 5 cosine 5x. And I believe you'll have a good final answer. It is a good final answer. It can be better if you write the positive term first. E to the minus 4x 5 cosine. By convention, you write the positive items first in an expression followed by the negative items. Minus 4 sine 5x, and you would be done. This is actually a better answer. So that pretty much brings us to the end of our video. I know I said that previous one was the last question. This right here was just a bonus question. I hope you enjoyed this video. I tried to keep this short and sweet and to the point with the rehashing of the exponential derivatives. Remember, the more practice, the better. And the better you get, the better the future concepts, which are harder, will be to you. They'll become easier to you. So please stay tuned. I have many videos on the way. And thank you for watching. Have a nice day.